In this tutorial, we're going to examine how you set up the linking process. In particular, we're going to look at the comparison levels and how you would go about estimating the M and U probabilities for the linkage. When searching for a link, we often have to, or we always have to rather, compare variables of different units. Ideally, we'll find exact matches in the variables, but we'll also allow for some small deviations. We do this by defining comparison levels. So for example, on date of birth, we have 3 comparison levels set in this particular example. We have what we would call an exact match. So that would be an identical match for the date, the month, and the year. And we'd consider this strong evidence that the 2 units are the same. We might have that there's 1 character difference in the 2 different dates of birth. So one might be on the 14th of June and one might be on the 14th of May of the same year. And that would be regarded as some evidence that there's a match. And then we would have all other comparisons, and that would be evidence against there being a link. Now, Splink contains a number of predefined comparison levels for various types of variables. What we're going to do in this tutorial is use the predefined comparison levels, so it will get us up and running faster in Splink. However, the comparison levels are fully customizable from within Splink, and you can do this using the functions custom comparison, which is imported using the Splink.custom-comparison library. In another tutorial, we'll have a greater look at how you would go about creating your own custom comparison levels. In this tutorial, we're also going to examine the estimation of the model parameters U and M. Recall that U is the proportion of records that will fall into each one of the comparison levels when 2 units are truly non-matching records, whereas M represents the same proportion of records that fall into each comparison level when you have truly matching records. Now we use Splink to estimate this. We won't go into depth now about how these algorithms work for estimating U and M. And there's also ways that you might estimate M and U yourself if you have some extra information about the data that's not contained inside the data set. Lastly, we're going to have a look at some of the visual tools that are provided for in Splink. These help you analyze and get a handle on the values of M and U that you've estimated. The functions here are listed below: visualizations.matchweights, visualizations MU parameters, visualizations parameter estimate comparisons, and a chart which shows the unlinkable units, and we'll talk about these at the very end of this tutorial. As in the previous tutorial on blocking rules, we're going to use the dataset fake 1000, which is provided in Splink. So we'll go ahead and we'll import that dataset now. And now we'll look at the first use of the comparisons library provided for in Splink. Okay, So we're importing the comparison library, and we're calling it CL, and we're defining a city comparison to be a Levenstein at a threshold on the variable city, and we're going to make it a level 2, or rather the Levenstein distance is going to be less than or equal to 2. And then we print out in a human readable form what this comparison level looks like. So in this case, the Levenstein in at thresholds of city has comparison levels which look like this. City is going to be defined as null if either city 1 is null, city left is null, or city right is null. We're going to have an exact match if city left is identical to city right. We're going to have a Levenstein distance of city less than or equal to 2 if the Levenstein distance really is less than or equal to 2, and in all other cases we're going to have a not match. So in this example you can see that you can use the Levenstein threshold in a unique way for each of your different variables. However, Splink goes further than this, and it has predefined comparison levels for different variables, and we will look at one now. In particular, we're going to look at one for email. So here we have the email comparison, which is predefined inside Splink, and the comparison levels are here written in human readable form. Again, we have, if one of them is null, then the comparison level will be null. We can have an exact match on the email addresses. We can have an exact match just on the username. We can have a Jarrow-Winkler distance of greater than 0.88. We can have a Jarrow-Winkler distance of 0.88 just on the username, or we can have all other comparisons. So this is provided for by Splink. So with this in mind, we're now at the position where we can essentially define what our model is. And here is an example of how to go about doing this for the fake 1000 dataset. So we import linker, settings creator, the block on function, and the DuckDB API. And the syntax looks like this. So we have settings defined in this settings creator function. We define the link type to be dedupe only. And we set our comparison levels using these predefined comparison levels within Splink. So we have a name comparison on first name, name comparison on surname. We have a Levenstein at the threshold 1 for date of birth. We're going to do an exact match on city, but we are going to allow term frequency adjustments to be turned on for city, and we'll use the email comparison as defined in Splink. So here are our comparison levels. And the blocking rules that we'll use to do the predictions will be first name and city and surname. This option down here allows us to keep the intermediate calculations, and then we simply define linker using the linker function. When we run this, we won't see anything in particular yet. We've simply defined how we're going to specify the model. Now, in order to estimate the M and U probabilities, we first need to estimate the probability that two random records match. To do this in Splink, we use the following command: linker.training estimate the probability that two random records match. And we're going to set a probability of about 0.7. That means we estimate, from our general knowledge of the data, that if we use these blocking rules and this particular blocking rule, that we're going to find an estimate of what the probability that any two records that we pull at random are going to be true matches. When we run this, we see that Splink estimates that the probability that two random records will match is about 0.003, I guess. The effect of this means that 1 in about 335 comparisons are expected to be a match, with there being a total of just under 500,000 comparisons possible. We expect that we're going to get around 1,500 matches in total. Now we can move on to estimating the U and M probabilities. So now that we believe that approximately 0.003 fraction of units chosen at random are going to be true links, we're in a position to estimate the U probabilities. Now, Splink estimates the U probabilities using random sampling. You can increase the maximum number of samples that you do. Here we've chosen 1 by 10 to the power of 6, so 1,000,000. The higher you choose here, of course, the longer it will take, but the more accurate you will estimate U. So we'll run this cell. Here we simply see the output that the estimated U probabilities were done using random sampling, but that our model is not yet fully trained, and we need to calculate M values for these variables here. Now it's time to estimate these M probabilities. One issue for this is that you have to first define some blocking rules which include some of these variables, so you won't be able to estimate the M values for the variables that you use in the blocking rule. So we'll have to probably use this particular estimation process more than once. So this is what it looks like. Training blocking rule is we're going to block on the first name and surname, and then we're going to run the training session. So with such a small data set, that's a fairly quick thing to do. and we see that we haven't yet trained our model on the first name and surname, and some values of the M's are not trained for email. So we've now calculated some of our estimates of the M probabilities. And now we need to choose an alternate blocking rule to calculate the missing M estimates. So in this case, we will block on the date of birth and employ the EM algorithm again. And we see that the EM algorithm converged after 11 iterations, and that our model is not quite fully trained. There's some missing estimates for email. Now, in this particular case, it turns out that the email variable cannot be fully trained because we don't have all of the comparison levels being filled. In particular, we've got the null condition not being met. So we will move on now to visualizing what these M and U probabilities look like. So the first thing we're going to do when we look at the model comparative parameters is the following. We're going to use the match weights chart. So what this does, it tells us how much information each one of those comparison levels for each one of the variables makes. So when we're making a comparison of two different records, we start out with the equivalent match weight of minus 8.3861. So the evidence, before we've looked at any of the potential matches, is against two random records being true matches. And then we add in what evidence you get from looking at the first name. And what this shows us is that if there's a match on first name, then the match weight will increase by 6.4, or if it's not an exact match, but it has a distance of a Jera-Winkler distance of greater than 0.92, so the two strings look fairly similar, or very similar indeed, that will give us a match weight of 6 or 6.01. Then the third comparison level, if the Jera-Winkler distance is greater than 0.88, then will give us a match weight of 5.58. Third, if the Jera-Winkler distance is greater than 0.7, the match weight is only about 2. And for all of the other comparisons, you will get a match weight of minus 2.25. So this is how the first name in general affects each of the comparisons that we do, and whether there was what comparison level was found between the two records will determine how much this prior match weight is adjusted by the inclusion of first name. Similarly, you can look through surname. So having an exact match on surname increases the match weight by 6.4, whereas, for example, having no similarity between surnames decreases the match weight by minus 2.16. Date of birth also, so match weight of 7.8. So it's quite influential if you have exact match on date of birth. In fact, it's more influential than having, say, identical first name or identical surname, and having a Levenstein distance of less than or equal to 1 is a match weight of 6.5. And if there is no similarity at all, the match weight decreases by 1.11. Similarly, you can look at city and email. Okay, so now we're going to go and look at the proportion of record comparisons that fall into each of the comparison levels. So this is the M and U parameters chart. So, for example, amongst matching records, 49% of records are in the exact match comparison level on first name, whereas 15% of records are very close. They have a Jarrow-Winkler distance of greater than 0.92. And even when we've determined that there is a true match, we will still see that 20% of records do not match in either of the Jarrow-Winkler cases or have an exact match. However, on the non-matching record comparisons, we see that almost none have an exact match, that a tiny fraction have 1.89% have some Jarrow-Winkler distance of greater than 0.7, and almost all, 97%, have no match, no identical match or no Jarrow-Winkler distance match. And these comparisons can be done for each of the variables: first name, surname, date of birth, city, and email. Now, as you recall, we did 2 training sessions to calculate some of the parameters. So we'll have a quick look at the comparison of parameter estimates depending on what training session was done. So the command that we used for this is parameter estimate comparisons chart. Now, if you recall, on first name and surname, we were only able to estimate those parameters when we blocked on date of birth, because for the first training session we were blocking on first name and surname. So it tells us what the parameter estimates were in this case for each one of the comparison levels. And surname similarly. So, for example, an exact match when we blocked on date of birth for surname is 0.43, whereas with date of birth we were only able to estimate in the first training run, because the second training run was done using date of birth as a blocking rule. And here are estimates of the parameter. And it's the last which is the most interesting, because both city and email those parameters were estimated using both first name and surname as blocking rules, and again using date of birth as blocking rules. And it's comforting to see that the parameters are very similar no matter which set of blocking rules we used. So that's something that you would be looking for. Here you'll see, well, it wasn't the missingness, it was there were no Gerald Winkler greater than 0.88 on username matches, so that's why we were unable to estimate this particular parameter here. Lastly, what we're going to look at are the unlinkables chart. So it might turn out that we simply don't have enough information on some records to actually produce any link at all. So the unlinkables chart will give us an idea of what this looks like. And this is it here. Now it shows you that depending on what the threshold match weight is, will tell you how many records could possibly have got linked. So if you set the threshold to be really high, 18 for example, then in this case 28% of our records couldn't possibly get linked. If you set it more reasonably at say 6 or 8, the number of at 6, then we see that just under 1% of records couldn't be linked, they're unlinkable. If you set it at 8, then it's more like 2.6% of records can't get linked. Okay, so we've run through a basic examination of how you define the model in Splink and how you would go about estimating the parameters after you've defined the comparison levels. And now what you might want to do is you might want to go ahead and save this model. So this is done using the following command. So the settings are written into this file here. So this is the location where I'll be saving the file, and it's of type JSON. And if there's another file of this name here, we will overwrite it. And we have now saved all of the settings that we've created in this session. So when we come back to do our actual linking, we can simply load up these settings again and run the linking much more quickly.